Hello and welcome to Chapter 4, Section 3, Writing Functions. Usually, when you're learning to write functions, you're given an equation with one thing that changes. Your change is the x, and the answer is the y. So it gives you a series of x's to put in your equation, and you get to solve all of that to find your y answers. And that gives you a y for every x, and that's your coordinate for your coordinate plane. Now, the first thing they're going to do is give you a table and ask you from that to write an equation. Here's an example. They've given you all of these x's and all of these y's, and they want you to find a pattern. And if you look, what is it you need to do to get from 1 to -2? That's subtract 3. And from 2 to -1, that's subtract 3. So you're going to check this subtract 3 pattern for all of the others. That's subtract 3, that's from subtract 3. You know that this works. And now you can write the equation. You're going to start by writing 1 minus 3 equals -2. And this is your x, because these are all your x's. And these are all your y's, and you're going to substitute. So your equation becomes x minus 3 equals y. Any x that you put in here, you know you subtract 3, and you will get these y answers. Let's try it for something a little more difficult. Here we have a series of coordinates. We're going to take this and make a table. So we're going to make an xy table with 1, 4, 2, 7, 3, 10, and 4, 13. And we're going to see if a straight across multiplication or addition subtraction works for this. Well, right now I can tell you that 1 times 4 is 4, but 2 times 4 is not 7. So straight multiplication isn't going to work here. Let's try straight addition. 1 plus 3 is 4, but 2 plus 3 is 6. So that's not going to work. So if it doesn't work, it's going to be a combination of something, and it's not going to be ridiculous. So we're going to try times 2 to begin with. 1 times 2 is 2, and to get to 4, I need to add 2. 2 times 2 is 4, and to get to 7, I need to add 3. Well, that's not it. So let's try times 3. 1 times 3 is 3, and to get to 4, I add 1. 2 times 3 is 6, and to get to 7, I add 1. Ooh. Times 3 and plus 1 worked. Let's try the others. 3 times 3 is 9. Plus 1 is 10, 4 times 3 is 12, plus 1 is 13. So I've got times 3 plus 1 as my rule. And now I can sit down and write an equation. If I start with my x and I say times 3 and plus 1, I'm going to get my y. And I would usually write it like this. It's not easy, but it's not difficult. It just takes a little bit of checking. And they're not going to make them extremely difficult for you. So what I'd like to ask you to do is try on page 249, check it out, number 1. It is an easy one, just to make sure you can do this. And please, can I ask you, don't skip, check it out. They're the things that make sure that you can do it. It gives you the practice, the hands-on practice that you need while you're doing the notes. So pause it here, try check it out number 1, come back when you have an answer. For check it out number 1, it gives you 4 points, and you can see to get from x to y, each time it's times 3. So you know it's your x times 3 is going to give you your y. So your equation is 3x equals y. The next thing we have are vocabulary words. We have a dependent variable. Dependent is the output, the y, what changes because of what you did. Where the independent variable, that is the input, the x. That is what you change. And they're going to ask you to identify these two things in an equation. So here's an example equation. You get $5 an hour to babysit, and you babysat for 4 hours. How much did you make? And it's going to ask you, what are your dependent and independent variables? $5 an hour to babysit doesn't change. This always stays the same. This is a constant, so it's not one of the two of these. What you change is the hours that you work. You have some control over this. How much did you make is dependent on how many hours you work. So this is the dependent variable. This is going to be your answer, your y, where this is your x. If I work 4 hours and I multiply it by 5, how many am I going to make? So this is going to be x times 5 equals y. The function of x, and we read it f of x, f of x. And f is the name of the function. Randomly, it can be any letter. And x is the series of numbers that we input. So the dependent variable is y, and y is the same thing as a function of x. Y happens because of the rule of x, and the rule of x is the dependent variable. That's the x. What I need you to understand is that y and f of x are the same thing. And if y equals x times 3, then f of x also equals x times 3, because these are the same thing. It can be written both ways. Okay? So on to the questions that they're going to ask you. First off is identify the independent and dependent variables and write an equation in function notation. A lawyer's fee is $200 per hour. The independent and the dependent variables are at question here. Now, $200 doesn't change, so this is going to be your constant. Per hour, you determine how many hours that you work. That's your independent variable. And then the question is, what's the fee? Based on this, what's the total going to be? The fee is going to be the dependent variable. So, we've got your independent, or the number of hours. The constant is 200. The dependent variable is the fee, the total fee. So our equation is that $200 times the number of hours is going to equal the fee, and we're going to write that 200 times x equals f of x. Or, if you're looking at their example, they're calling their variable h. So f of h is 200 times h. Doesn't matter. Here I named my variable x. Here they named their variable h. Doesn't matter. The next problem. The admission fee to the carnival is $8 and the rides are $1.50 each. And the question is going to be, how much money did you spend? So that's your y. That's your answer. That's your dependent variable. It's going to cost you $8 to get in regardless. So this is a constant. And the rides are $1.50 each. This is a constant. The question, the independent variable, the one you have control over, is how many rides do you go on? So we've got independent variable is the number of rides. The constants are $8 and $1.50, and then the dependent is the total cost. And we're going to write that as 8 plus 1.5 times the number of rides is going to give us our total cost. And our total cost is going to be f of r, because r is our variable. You've got two sets of check it outs. One, numbers 2a and 2b just asks you to identify the variables, and 3a and 3b asks you to identify the variables and write the equations. So please push pause here and come back when you're done. So 2a gives us hours as the independent variable and the total cost is the dependent variable. 2b is the number of pounds as the independent variable and the total cost is the dependent variable. In 3, the independent variable is the number of pounds, the dependent variable is the total cost, and our equation is f of L, or whatever variable you choose, is 1.69 times L. For B, the independent variable is the number of people, the dependent variable is the total cost, and f of P, which is the number of people, equals 6 plus 29.99 times P. Okay? Please ask me if you have any questions. Now we go on to example 4. This asks you to evaluate the function for the given input values. This means solve the equation for all of the x's that I give you. And when you translate it, it just doesn't sound that scary. The first thing that says is for the function of x that equals 5 times x, you're going to find f of x, which is the answer, when x equals 6 and when x equals 7.5. Now this is just like when we had regular equations. I'm going to give you 2 sample x's. You're going to solve the equation. Tell me what y equals. So in each instance, I'm going to say 5 times 6 and 5 times 7.5, and we're going to solve for x. Then they change f to g just to say, yeah, we can do that too. 2.3t plus 10 is our equation, and t equals 2 and negative 5, and we work those out just like we have before. For h of x equals 1/2 x minus 3, where x equals 12 and negative 8. 1/2 times 12 minus 3, 1/2 times 12 is 6, minus 3 is 3. 1/2 times negative 8 is negative 4, minus 3 is negative 7. So we're just solving equations. Try to check it out, numbers 4a and b on the bottom of page 251. Push pause and come back when you're done. For 4a, h of c equals 2 times 1 minus 1 and 2 times negative 3 minus 1. And when we work all that out, I get 1 and negative 7. And for b, when we work it all out, 1/4 of 24 is 6 plus 1 is 7. 1/4 of 400 is 100 plus 1 is 101. All right? And section 5 asks us to find the reasonable domain and range of a function. Please remember domain equals x and range is y. So this word problem, Manuel he's already sold $20 worth of tickets. He has 4 tickets left to sell at $2.50 each. Write a function to describe how much money he can collect from selling tickets total. He has 4 tickets. He could sell 0, he could sell 4, he could sell anything in between. So the reasonable domain of this problem is anything from 0 to 4. And we have to spell them all out because this question asks us all of the digits. And then our reasonable range means we stick all of these x's in this problem and we solve for all of them. So our reasonable range is all of the answers to all of these questions. And that's it. So try check out number 5, push pause here, give that a shot and come back when you've given it a try. So we had the number of watts used for each setting is 500 times the setting number. So our domain is all of the setting numbers, which is 0 through 3, and we have to spell them all out. And then we have to stick these numbers in for x and give the range. And that was it. Your homework starts on page 253. It's numbers 13 through 28. Please make sure you ask me if you have any questions, and I will see you tomorrow.